Here we go with example 2, parts D, E, and F. They're going to be very similar to each other, and you will find similar things on homework as well. All right, we have that function again, x squared plus 25, or x squared plus 5, pardon me, the interval from 0 to 4. This time they want us to revolve that curve around the y-axis. And here again, the y-axis, as we all know, is this here beautiful vertical line with the equation x equals 0, isn't it? Okay, so here we go again. Now, we're going to take that thing and revolve it around a vertical line. So that would be Roman numeral number 3 in our notes. And if we're going to take a function and revolve it around a vertical line, vertical lines in general are x equals a number. And here you go again. If the description in the question is y-axis, everybody all together now, you remember? Hello, my name is y-axis, but my friends call me x equals 0. Isn't that how you say that, Grayson? Yeah, exactly. Okay, so x equals 0. So 0 is our k value that we've been talking about throughout these. Now look, if we revolve this thing around that vertical line, the mirror image of this thing is going to hit the board over here, and it just looks like in general this would be this bowl here. And we're looking for the surface area. Let's not confuse this with the volume assignment that we had before. So, the corresponding picture I'd like you to see would be a cylinder standing upright here. And so here would be height, and then radius, as mentioned before. On a nice circular cylinder, the radius is always the same number, but here, the radius is changing all the time as we travel from 0 to 4. So every value of x between 0 and 4 would have a different radius corresponding to it. So I hope you see the general picture there again. We are once again going to use the lateral surface area of a cylinder. Let's keep in mind we're not worried about the circles at the top and the bottom here, just this lateral surface. All right, so 2 pi RH would still be the deal, but this time the orientation of our cylinder is upright. Okay, so what I hope you would agree with would be that our surface area for this object over here, capital S, is going to be 2 pi. That's just part of the geometry formula there. The height would correspond to the length of the arc. So that would be the same expression. Take the derivative of your function, square it, add 1, put a square root over it. I think that's going to stay the same here, isn't it? Because the height would still correspond to the length of that arc. The radius expression, however, you got to think about as we travel from 0 to 4, we're considering every single value of x between 0 and 4. And so for every value of x, as that integral travels from 0 to 4 and basically calculates this for all the values of x between 0 and 4, there's an infinite number of them, wouldn't the radius for that particular value of x be the distance between that value of x and our axis of revolution? So in this case, it would be whatever the value of x is minus the axis of revolution, 0. So you'll see in your notes, and you can follow the cookbook if you want. Here we go. Since our radius this time is a horizontal type of creature, it would be x minus k rather than f of x minus k. So that's really the major difference between these examples and the A, B, and C that we did earlier. And that would be the setup of that. And x minus 0, of course, is just x. And, as I think about it, I think you could use substitution to do that integral, but we're not even going to have you evaluate them. But as I see it, that would be part D. So hit freeze, clean it up if you want to. That doesn't really matter to me. And go ahead and evaluate it if you want to, okay? Nicholas, if you want to do that, that's fine with me. All right, now let's go ahead and do part E. Let's see here, part E. Now we want to revolve it around x equals -3. And so this really can be built off of the previous one. X equals -3, once again, would indeed be a vertical line. What's that doing to our picture here? Instead of being here at 0, It's going to be back here at -3, the axis of revolution, that is. So let's change that to x equals -3. Trying to recycle some things here because this next picture is very similar to the previous. If you come back here to x equals -3 and make that vertical line, I hope what you're seeing as we do these side by side is that the one thing that's impacting is the radius, isn't it? So now you take this thing, you revolve it around, and it basically widened it out a little bit, right? The bowl that we were talking about earlier got widened out a little bit, and the impact of that would be that all of these radius expressions got increased by 3, didn't they? 3 more units. I hope you understand and agree that the height is still arc length. So that's not impacted at all. And that is, I hope, reflected in the notes that are given to you. See, this is the same height expression that it was on the other examples earlier. That's not going to change. But the radius expression this time would be the distance from, as you travel from 0 to 4, as that integral travels from 0 to 4 and puts every value of x in here, the radius for every value of x would be x minus -3, wouldn't it? X minus -3, which indeed then becomes x plus 3 when you clean it up. But again, you don't have to clean it up if you don't really want to, all right? So Devin, just leave it like that if you want to. Clean it up, I don't care. That's it. Okay, now, I think we're gonna have to redraw the picture quite a bit here to do part F. So, and I hope what I'm doing here, building one example off the other is making sense to you. Your challenge when you do the assignment is to just figure out which of these different scenarios is involved in your specific question. And I'm trying to do an example of every possible scenario. All right, so x equals 7. That's vertical, isn't it? Okay. I'm going to redraw this because this gets a little bit messy if I'm not careful. So we go back to our original curve and our original interval from 0 to 4. 0 to 4 ordered pairs. Really, the plotting of the f of 0 and the f of 4 doesn't end up really mattering. This time, the axis of revolution is out here, note, above the interval, out here at 7. And so we're taking this original curve here, and we're revolving it this way. And so the mirror image is going to hit the board over here, and I guess this would be the way I've drawn it, kind of a volcano looking thing, whatever. Picture doesn't have to be perfect, just to help you set up the question. So, as far as my analogous picture over here of a circular cylinder, I hope what you're noticing here is that this time the original side is over here on the left. And I hope you would agree, you know what, the height's still going to be the same. That didn't impact that at all. The length of this arc would represent the height of that so-called cylinder. And so that will be exactly the same. What's happening here is, once again, the radius expression is being impacted by this. So see, this time, as you travel from 0 to 4, as the integral travels from 0 to 4 and considers every single value of x, the question would become, when you get to that specific value of x, what would be the expression that would represent that particular radius? And once again, on a nice circular one, it's always the same. It's always the same number. Radius is always the same number. Here it changes. I like to call it the radius expression. And so, what do you all think? Yeah, I heard you all say it all at once. Wouldn't it be 7 minus x? Indeed. Because again, if x lives between 0 and 4, then x is going to be smaller than 7. So that radius would be 7 minus x this time. And there you go. In our general notes, just to cover that base, is it possible that the k and the x could be trade places? Yeah, it just depends on their relative positions. So you'll have lots of space on this homework to do each of these questions, and I would just simply ask that you draw a rough picture of the question, if you would please, and then all we're asking for once again is the setup of the appropriate integral. This would be extremely difficult. We wouldn't even know how to integrate this one using substitution and things of that nature. So, yeah, we might be able to. Yeah, maybe we could do this. I don't know, but don't worry about it. Set it up. There you go. So that takes care of that entire assignment as far as I'm concerned. We covered every scenario, and that should enable you to do assignment 33 now. So good luck on that one. I miss y'all. Hope you guys are doing well.